Welcome back to the deep dive. I have to be honest with you. When most people hear the phrase AI ethics, their minds usually go to some very specific, usually very dramatic places.
Oh, definitely.
Right. Like they picture the Terminator stepping on a human skull.
Uh.
Or they picture that classic Philosophy 101 thing, the trolley problem,
Ah, yes, the trolley problem. A classic for a reason, but yeah.
where the self-driving car has to choose between hitting the grandmother or the baby. And it's all very high stakes, very sci-fi. But honestly, it feels totally disconnected from the reality of actually building software.
Right. It feels like something you debate over a glass of wine.
Exactly. Not something you actually code into a system on a Tuesday.
It is fascinating stuff, don't get me wrong. But in the real world of deploying technology, those end-of-the-world scenarios are actually, well, they're a bit of a distraction.
They really are.
They take the focus away from the mundane errors that actually hurt real people today.
Which is exactly why today's deep dive is going to be a bit of a hard pivot. We are looking at a paper by Sue Eze. It's titled, When Ethics in AI Becomes Actionable.
It's a fantastic paper.
It really is. And the core argument here is that the real urgent issue isn't about sentient robots taking over.
Yeah.
It's about something much more boring, but frankly, much more dangerous. It's about foreseeability.
Right. The core question isn't whether this AI is evil.
Nobody is programming evil AI.
Exactly. The question is, when this algorithm makes a mundane mistake, a glitch, a bad prediction, a sensor error, can we predict it? And if we can predict it, are we liable for it?
And that is the mission of this deep dive. We're going to explore what Eze calls the foreseeable harm boundary. We're moving away from the abstract debates of good versus bad, and we're getting right into the gritty details of safe versus negligent.
We are effectively moving from philosophy to engineering, and to law, really.
Yeah. And for everyone listening, if you think this is just legal jargon, stick around, because by the end of this, we're going to explain how something as annoying as a glitchy alarm in a nursing home can actually become legal evidence of negligence.
It's a bit of a wake-up call for anyone managing these systems.
It really is. And we're going to look at the specific tools, actual code that lawyers can use to prove it. So let's unpack this. The paper starts by drawing a really sharp line between two concepts that I think we usually just mash together in the industry: ethics and governance.
We absolutely use those words interchangeably.
I do it all the time.
Most people do. But the author argues they are totally different beasts. And the distinction is vital if you want to stay out of court.
How so?
Well, according to the source, ethics starts from within. It relies on things like conscience, intuition, professional discretion. It's that internal feeling of what you ought to do.
So it's basically a vibe check. Like, I feel like this is the right thing to do.
Exactly. It's subjective. But
Right.
governance cannot run on vibes.
No, it cannot.
Governance needs an operational threshold. It needs to be enforceable. You can't regulate an entire industry based on a developer's internal moral compass.
Because everyone's compass points a little differently.
Right. You have to regulate based on measurable risk, safety impact, and here is the key word, foreseeability.
Foreseeability. And this brings us to a legal concept the paper highlights, which I actually found really grounding: the reasonable professional standard.
Yes. This comes from classic negligence law, specifically a case called Donahue versus Stevenson for the legal history buffs out there.
That's the one with the snail.
The very same.
Yeah.
It involved a decomposed snail found in an opaque bottle of ginger beer.
Oh, gross.
Very gross. But the legal principle that came out of it is massive. The idea is that the law doesn't ask, was this manufacturer evil? Or did they intend to poison the customer?
Of course they didn't intend to.
Right. The law asks, could a reasonable, informed professional have predicted that a snail might get in there if they weren't careful with their bottling process?
That's a huge shift when you apply it to tech.
Yes.
Because if I build an AI system and it hurts someone, I can't just throw my hands up and say, well, I didn't mean to. Or, AI is a black box. Who knows how it works?
Precisely. That excuse is dying. If a reasonable professional in your field would have looked at the data and said, hey, this looks risky, and you didn't act on it,
Then you're in trouble.
that's not an ethical lapse anymore. That is a governance failure. The paper argues that when harm is foreseeable and preventable, ethics stops being a theoretical debate and it literally becomes a duty.
Okay, so that's the theory.
Yeah.
But I want to make this concrete for you because the paper uses a really specific, really high-stakes example to illustrate this.
Yeah.
We were talking about CareTech and the WEDA fall dataset.
Right. So imagine a nursing home environment.
We aren't talking about ChatGPT writing poems here.
No, not at all. We are talking about wearable sensors, Wristbands with accelerometers and gyroscopes worn by elderly residents.
And the goal of these wristbands is pretty straightforward, right? Detect a fall.
Correct. The system is continuously monitoring movement data. It's looking at speed, rotation, impact, and it's trying to distinguish between a fall, which the dataset labels as F011 to F08, and activities of daily living, or ADLs.
ADLs being things like sitting down in a chair, waving your hand, clapping, maybe picking up a remote control.
Exactly. Normal life, just moving around. But here is where the foreseeability problem kicks in. The paper outlines two main error modes or scenarios that create liability, and they show exactly how glitches translate to harm.
Let's break them down, because scenario A is the obvious nightmare.
Scenario A is the false negative. A resident falls, they are on the floor, maybe they've broken a hip or hit their head.
Awful.
But the AI looks at the sensor data and thinks, oh, they just sat down quickly, so no alert is sent, no nurse comes. This is direct, foreseeable physical harm.
Yeah, that one seems pretty clear-cut. If your fall detector doesn't detect falls, it's broken and people get hurt.
It fails its primary function.
But scenario B is the one that really blew my mind. Because I think we've all experienced the annoyance of technology that just beeps too much.
Yes. Scenario B is the false positive, the cry wolf scenario.
The resident just waves their hand to say hello to their grandkids, and the wristband screams, fall detected.
And you might think, well, better safe than sorry, right? At least the nurse checks. That is a very common defense in the industry.
Sure, over-alerting feels safer than under-alerting.
But the paper argues that this is actually a massive safety risk. It causes what's called alert fatigue.
Alert fatigue. It sounds exhausting just saying it.
It is, and it is dangerous. If the device goes off every single time someone claps their hands, the nursing staff stops reacting quickly. They assume it's a glitch.
They finish charting their notes before they go look.
Exactly. They walk a little slower. They finish what they are doing. So when a real fall actually happens, the response time is severely delayed.
Or the system has trained them to ignore it.
That's it exactly. The author, Sue Eze, points out that this is an indirect but foreseeable safety risk.
Wow.
If you deploy a system that you know has a high false alarm rate, a reasonable professional should predict that staff will eventually ignore it. Therefore, the harm caused by that ignored alarm is actually your fault as the developer or deployer.
That is a crucial realization. A glitchy, annoying system isn't just a nuisance or a bad user experience. It's an actual safety violation.
It is, and that's exactly where the legal liability attaches.
This brings us to the core concept of the paper, the Foreseeable Harm Boundary, or FHB. The author creates an actual threshold for this. How do we know when we've crossed from a simple oops to actual negligence?
She defines it very clearly. The FHB is crossed when three things meet. First, the harm is observable. You can see it in the data. Second, the harm is predictable. It's not a freak accident. It happens consistently. And third, the harm is preventable through controls.
Observable, predictable, preventable. I love how the paper contrasts this with things that don't cross the boundary, like the more theoretical ethics stuff.
Right. So if we are arguing about the color scheme of the app being unpleasant, or maybe the tone of the chatbot text is a bit rude.
Sure, that's bad design. Maybe it's not nice.
But it doesn't trigger a governance duty because it's not clinically harmful.
Or what about speculative worries? Like, what if the AI becomes sentient in 50 years and locks the doors?
Exactly. That is not actionable. You can't regulate against a sci-fi plot. But if you have systematic missed falls or recurring false alarms that ruin staff response times.
Which we just talked about.
Right. Or even device non-wear patterns, like the battery dies every day at 2 p.m. and you lose monitoring coverage for an hour. That is actionable.
So the shift is, once you cross this line, observable, predictable, preventable, you can't just have a committee meeting about it anymore. You have to fix it.
You have a legal duty to act. It's no longer optional.
But here's the tricky part. And I think this is where the paper gets really technical, but also really cool. How do we prove it was foreseeable?
That's the million-dollar question.
Right. In a court of law or to a regulator, how do we prove the developers, quote-unquote, should have known?
This is where we bring in the heavy artillery. Explainable AI or XAI. The paper specifically focuses on two tools, SAP and LIME.
Now, I've heard of these in the context of debugging code, like figuring out why the machine learning model made a weird mistake so the engineers can tweak the algorithm. But the author is saying these are legal evidence now.
Yes, they aren't just for the engineers anymore. They are for the auditors and the lawyers. Let's start with SHA. SAP gives you the global view. It shows you the big picture of what is driving the AI's decisions across the entire data set.
The paper mentions a beeswarm plot. Can you visualize that for us?
Imagine a cloud of dots, thousands of them on a screen. Each dot represents a specific decision the AI made. The SHAP B-swarm plot groups these dots to show consistent patterns.
Okay, I'm picturing it.
So for example, in our nursing home context, the plot might show that the feature low staffing levels or repeated infection control failures pushes the risk score up every single time.
So if I'm looking at this plot and I see a giant red blob that clearly says low staffing equals high fall risk, I can't pretend I didn't know staffing was an issue.
Exactly. The data makes the risk observable. If the AI is consistently flagging facilities with low staffing as dangerous and you, the operator, ignore that signal, you're ignoring foreseeable harm. You have the map right in front of you.
That is powerful. It's almost like the AI is telling on the management, like, hey, it's not my algorithm failing, it's the fact that you only have one nurse on duty for 50 people.
Precisely. It surfaces the operational flaws.
Yeah.
And then you have Lime. While Esche looks at the whole forest, Lime looks at a single tree. It zooms in on one specific case.
So why was this specific facility flagged? Or why was this specific fall missed?
Right. Lime points to the specific operational features that caused that one decision. Maybe for this one resident, the system failed because of a specific movement pattern, like a Parkinson's tremor, that the developers knew was tricky for the sensors, but they didn't fix it.
And the paper adds one more layer to this evidence sandwich. Counterfactuals. Which sounds a bit like alternate history to me.
It effectively is. Counterfactual analysis asks, what if? It allows you to run the model backwards, essentially, and say, okay, the risk score was high, but what if we had increased the registered nurse hours by 10%?
And if the model says, well, if you did that, the risk would have dropped to 0.
Then you have just proven the harm was preventable.
Wow.
That is the nail in the coffin for a negligence defense. You knew the risk, that's foreseeability via SHAP, and the model proves there was a way to fix it. That's preventability via counterfactuals. If you didn't do it, that is negligence.
That is wild. It really turns explainable AI from a nice-to-have dashboard feature into a keep-you-out-of-jail feature.
It absolutely does. It transforms technical metadata into legal discovery.
So we have the theory. We have the case study with the wristbands. We have the evidence with SAP and Lime. Now let's talk about the rules, the so what of it all. The paper lists a bunch of governance frameworks, ISO 42001, the EU AI Act, GDPR. How do these actually connect to what we just talked about?
So all these frameworks are basically saying the exact same thing, just in different legal languages. You cannot just launch and leave.
Launch and leave. I like that phrase.
You can't just put the software out there and wash your hands of it. ISO 42001, which is the big international standard for AI management systems, it requires a risk register.
Okay.
If your SAT analysis shows a risk, like that staffing issue we talked about, it must go in the register. And if it's in the register, you must have a control for it.
It connects the dots between the code and the management?
Yeah.
You can't claim ignorance if it's literally written in your own risk book.
And the EU AI Act is even stricter. It requires post-market monitoring. You have to keep logging data after the product is sold. You have to actively watch how it performs in the wild.
And GDPR brings in the fairness aspect, doesn't it?
Right. If SH shows that your fall detector works perfectly for wealthy facilities with high-quality Wi-Fi and lots of staff, but fails constantly in under-resourced ones.
That's a huge fairness issue.
It is. And under GDPR, if a specific demographic or group is consistently getting worse predictions, and that is visible in the data, you are accountable for that bias. It's no longer an invisible ghost in the machine. It's a chart on your desk.
There was one point in the paper that really stuck with me about the duty aspect. It said that having the logs isn't enough. You actually have to read them.
This is the most critical part for any human-in-the-loop system. The risk isn't just the AI making a mistake. It is the unmonitored use of the AI.
Unmonitored use.
The paper explicitly mentions regulatory reviews in the UK. They have criticized deployments where the alarms were generated, meaning the AI actually did its job perfectly. But nobody triaged them. The alarm rang, and no one came.
So if the system generates a log that says, hey, there's a problem here, and the human operator ignores the log, the organization is liable.
Yes. You cannot blame the algorithm if the algorithm screamed for help and you were on your lunch break. The foreseeable harm boundary puts the responsibility on the system operators to actually read the data they are collecting.
It feels like this entire paper is a massive reality check for tech companies. For a long time, I feel like the AI is a black box was a perfectly valid excuse in the industry. You know, it's machine learning, it's too complex for a human to understand. Deep neural networks are just mysterious.
That era is completely over. That is the main takeaway here. Explainability tools like Shape and Lime turn the question of should we worry into this risk is material.
Your tools exist.
If the tools exist to look inside the box and you choose not to use them, or you use them and ignore what you see on the screen, that is on you.
And specifically in healthcare, the stakes are just too high.
Oh, absolutely. The tolerance for unknowns in health and safety is incredibly low. If you are recommending a movie on a streaming app and you get it wrong, who cares? The user watches a bad rom-com.
Right. Nobody gets hurt.
But if you are watching a vulnerable elderly person, you don't get to say, oops, the model hallucinated.
So if those plots exist, if that SHAP beesworm plot has been generated on a server somewhere, and it shows a risk, you effectively cannot argue in court that you didn't know.
It would be very, very difficult. The evidence against you is literally generated by your own system.
It's amazing to think about how far we've come in this conversation alone. We started with the trolley problem, abstract philosophy, sci-fi robots, and now we are talking about reading SHAP values to prevent your grandmother from falling and breaking a hip.
It's a necessary journey. I think for a long time, AI ethics was treated as this soft, fuzzy layer on top of the code, a nice-to-have PR thing. But Sue Eze's paper shows that ethics is valuable for company culture, sure, but governance is for safety.
And the foreseeable harm boundary is that line.
It is the line where we stop debating and start fixing. If it's observable, predictable, and preventable, you have to fix it.
I want to leave you with a thought here, something to mull over. We've been talking about nursing homes today, but this applies to so much more. Finance, hiring software, autonomous driving.
It does. It applies to literally any system that impacts human beings.
So think about the systems you use in your own work, or even the systems you manage. Are there glitches? Little annoyances, false alarms, weird data errors that you're just ignoring? Things you've learned to live with because, well, that's just how the system is.
Because if you looked at the data, really looked at it with these tools, would those glitches actually look like foreseeable harm? Are you ignoring a warning light just because it's been blinking for a month?
That is a terrifying and important question. Definitely something to check on Monday morning.
Better to check it now than explain it to a regulator later.
Thank you so much for walking us through this. It really changes how I look at those boring governance documents.
My pleasure. It turns out the boring stuff is the most important stuff.
It usually is. Thanks for listening to The Deep Dive. We'll catch you next time.